type thing to bring back a lot of information that makes it easy to see what's going on. But it also helps someone who's, again, new to Cisco to know which commands to type.
Yeah.
Because like all the OSPF commands, some guys might not know what commands to use. And this just makes it really easy for you. So that's great. But Hank, I want to ask you something really simple. Can you go back to the console of that switch, or that router, sorry, the serial port?
Yep, I still had it open over here. Yep.
So can you type show line in there?
Show line. I can indeed.
Yeah, so I just wanted to make this clear, because in the VIRL terminology, they're talking about serial ports, serial 001, and that might be confused with a traditional serial port. So what we're actually doing here is we connect it to the console port, aren't we?
Correct. Yeah, 01, serial 1 would be the aux port of the device, as you can kind of see if you look in there, and then serial 0 is the console. You could telnet into the management ports, the kind of the traditional VTY lines as well, but in this case, the connecting to serial 0 again. That's a console port.
Yeah, so we can see the console port is in use there, just like you would on a traditional router. So that's great. Yeah, thanks. I just wanted to confirm that.
Oh no, absolutely, great question. So we got those, and so that's the live visualization editor. Where was I? And then over here on the tab, and then if you wanted to connect directly into the pieces as well, they're ports you can come through to connect. And so some of these other external connections. So if I just click on, yep, I want to open that up. Allow. And so what that did is this URL of telnet : //10.10.20. The telnet : instead of like HTTP is saying, hey, I want to open up a link to a telnet app. And then if you've got a reference to what application to use to open up telnet on your local machine, and on my case it's a Mac, and my Mac is going to try to open that up in a terminal app, it goes ahead and actually will launch it. And it looks like I wasn't actually set up. My sudo TTY isn't set up to do that, but those links will sometimes work for those depending on your underlying platform on those pieces. But that's what these external are. So if you had an application set up, you could click these to launch rather than in a web. Though over here, we can see these under options. I can go ahead and just click. I'm already connected to iOS v1, so I won't do that one. But here, the console 0, again, that's going to be the console port on iOS v2. If I click on that, this will give me that same spot I was just at. So I don't have to go through that live visualization page to get to them. I can do it right from the simulations view and just get back in. And again, just as a reminder, it's here under the options, console 0.
Yeah, I mean, that's brilliant. So I could use Teraterm, PuTTY, whatever my favorite terminal emulation program is to access these VIRL console devices just by telnetting to that IP address and port number.
I'm actually, in a very few minutes, we're actually going to jump over and I'm going to show you how I would recommend people when you want to get out of the web interface and start using like terminals and pieces. We've got something even better that I think you might like on that side. So
great.
Hold on to that one.
Right.
But from the web interface, kind of sticking in this kind of GUI experience, we've got, again, console 01 or management. So I can click the M with the piece that's there as well. Let's see if one of these ones aren't grabbing it. Normally those open up. Oh, you know what it is? These management IP addresses aren't routable. So these addresses here, this 10.255, those are internal to this topology, the way it was built up. So I wouldn't be able to telnet directly to these addresses. This 10.10.21 is. If these were routable addresses in there, these buttons would open up a tab to telnet directly into those devices. But just the way that this topology was built, these aren't using what would be considered kind of a routable management inside the network plane that's there. Excuse me. All right,
I mean, Hank, just to reiterate, because I'm a bit slow at times, again, this is just using your web browser. Yeah. It's using a VIRL VM. In this case, it's hosted in DevNet, but the same thing applies if I was running VIRL locally on my ESXi server or my laptop, whatever. Just use a browser to access all of this stuff.
Yeah, again, if someone does have VIRL of their own, just go to the web, go to the web interface for it, log in, and all of these pieces are there. We're not going to dive into those just based on time, but again, VIRL gives you the ability to do traffic captures that are there. We can see the interface list that's out there, all the link details. There's lots of other pieces that you can jump into on that. But for now, what I want to do is I'm actually going to stop this simulation, and we're going to look at, as I hinted at, using the web interface is a great way, particularly if you're trying to learn or study for something and go through. But my use case for I think I gotta hit the confirm on that one. Let me go back in. My biggest use case for VIRL these days is as part of something that I'm doing from a network automation perspective, or from a net DevOps, or trying to do config management or learn some new tool there. I just gotta go actually confirm that I really want to stop it. Stop simulation. I actually kind of appreciate that it wanted me to confirm that I wanted to stop it and didn't just wipe out all that work. There we go, request stop. All right, so this is gonna go ahead and stop the simulation. Now I'm stopping this mostly just for the load. We're done with it at this point, but VIRL does allow you, if you have enough capacity from a CPU, memory, licensing perspective, you can have more than one simulation going. And in fact, that large sandbox that we looked at before, sometimes I'll have 2 or 3 in there showing different demos all on one VIRL server. It's just you need to make sure you've got enough kind of CPU and license for whatever you're after in that case. This particular server only is licensed for, again, I think 6 simultaneous Cisco devices, and so I wanted to free up those extra 3 that are there on that. All right, so simulations are done. Before I jump into the next bit, do you have a question, David?
No, that's great. I mean, it's. I think the exciting piece here is, I mean, for those people who didn't know, you can get free VIRL access through DevNet. Big thing is it's multi-vendor. Another big thing is you don't need to install the Maestro software. You can just use the web browser. Those are the big things I've learned so far.
Yep, absolutely. All right, so now we're going to talk about how we can use VIRL as part of our network automation and simulation pieces. And so what we're going to use, we're going to drive VIRL through the APIs that are there. And so VIRL, since its launch, has always had APIs. And in fact, if we come over here, you can find them in the documentation. You can look at the different APIs that are available. But what we've done is we actually built a tool called VIRL Utils in Python. So I'm just going to go here to PyPy. If folks aren't familiar with the Python package index, it's a place where you store things, Python libraries for people to download. And so this is if you've ever done pip install netmiko or pip install requests, it's installing it from PyPy, which is this service. And so we've got a package up there called VIRL Utils. And so we can see, I'm going to go to the actual GitHub page because the docs read better over there. What VIRL Utils is it's a CLI tool for interacting with VIRL, and we built it specifically for kind of network automation, net DevOps style use cases. And it's modeled after another DevOps tool called Vagrant. Vagrant is an open source tool from a company called HashiCorp, and it's a CLI wrapper for managing kind of VM. Originally, it was kind of software developers' VM environment, so loading up their servers, managing their deployments, so that it was easy for software developers to quickly start up and tear down and replicate their development environments. And so what we wanted was a similar thing for network simulations, and so VIRL Utils gives us that same type of model. And so we can see here, VIRL up is where we're going to start out with some of these pieces, and it's a command line tool. And we'll have links to all of these things inside of the show notes. But the installation, there's different ways to install depending on whether you're trying to develop with it. But the way that I tell most folks is just pip install VIRL Utils. And I've already installed it, so we'll see that it's already satisfied. And so now I've installed the command line tool, VIRL. And if I do VIRL -- help, we can see this is similar to what we saw in the GitHub documentation. It shows me all the commands that are there. And so what VIRL Utils is doing is it's interacting with the VIRL server under the hood. And in this case, it's the same VIRL server we were just looking at. And so I can come in here, and the first thing we might want to do would be typically to start up some sort of a simulation. We know we don't have any running right now, and so where do I start from? Well, we built in this thing called VIRL Search, and so we've got a GitHub repository where we've got some sample VIRL topologies. And so if I just type VIRL Search, we can see here that we've got, it looks like about, 9, 10 different topologies that we can grab. And so we've got a 2 iOS router, we've got a 5 router mesh, we've got a core access distribution. And so I can grab any of these and use these as a starting point if I don't have my own topology file. But I want to reiterate, remember, when we were working in whether VM Maestro or the web interface, what we were creating was just a topology file, and you can download those. And so if you've built a lab topology in VIRL, you can save that topology file off as just the topology file, and you can use those. But in this case, we're going to grab one from GitHub there. So I'm going to do VIRL up and say, I'm going to VIRL up this VIRL files 5 router mesh.
Sorry, Hank, just a dumb question while we're waiting for that. where did you install this software? Is it on your Mac or is it on the VIRL server?
It's a good question. So right now, this is just my Mac. We're looking at the SSH terminal for my Mac. You could run this on a Windows machine, on a Linux machine, anywhere. It's a Python package. So the requirement is Python. These days, I recommend everybody Python 3, but it does work with Python 2 as well. And so it's just wherever you happen to be working from, just pip install VIRL utils, and I'm working locally from my Mac, and then it's going to connect to the VIRL server that again is in the sandbox that's there. And we'll talk in just a second about how VIRL utils knows where that server is. But yeah, I'm running locally, working kind of remotely controlling the VIRL server that's out in the cloud.
Yeah, great. So rather than having the VM Maestro software as a GUI, this is kind of like a CLI client that's talking to an API type thing. Is that right?
Yeah, that's exactly what it is. Yep, it is a CLI client for VIRL, and there's so many use cases for it. We're going to work on one here, just kind of from a terminal perspective, kind of working with manipulating, managing our simulation. But you can also use this kind of in more advanced use cases, which is what we're starting to see is part of kind of automated testing pipelines for different types of configuration strategies. And so if you work in a big enterprise, you're using Ansible to drive your network configuration. Well, you could use VIRL utils to spin up a network simulation that looks like your corporate network, deploy your updated scripts, test that they're all working fine, and then again, using this command line tool, tear it down when you're done. And that was the big driver for VIRL utils, was to provide an easy way to hook VIRL in as a network simulation and a testing platform to provide the basis for those types of what we're calling network configuration pipelines, a way to kind of quickly bring up an environment, run a configuration against it, test it, make sure it's good, tear it back down in a way through that. Does that make sense?
Yeah, no, that's great. That makes a lot of sense.
Mm-hmm. Cool. All right, so by now we should be close to there. So now if I do a VIRL ls, this will show me that I have a simulation running and kind of linked to my current client that's there, and I can do VIRL nodes to take a look at what VIRL nodes the status is. And so we can see in here I've got 5 nodes. The one I started up again was a 5 router mesh, so it's just 5 kind of IOSV nodes. You see they're all there. They're active. Looks like they're still not quite fully up yet because they're not reporting reachable status, but we can see that they'll be available via telnet. And in this case, these management addresses, these ones will be routable. So I could SSH and telnet directly to those. Go ahead and run this again because in a second they'll start reporting reachable. But let's talk about interacting with these, because some of this stuff we can actually go through. If I do VIRL -- help once more, we can see I've got a couple of different things in here I want to point out. This first one is console. I can console into a node. There's also SSH to a node and telnet to a node. And so I can go through and say VIRL console and then give it a device. And I'll just grab this one that I can still see here at the bottom of the line, iOS v-5. So VIRL console iOS v-5 will try to connect me directly to the console of that device. And so again, I'm on my Mac using the VIRL utils tool to jump in. And so now I'm connected to the console port for iOS 5. And I could enter enable mode, and it will do the same thing, show line. And we can see I'm again attached to line 0, the console port that's there. And I've done that under the hood. What VIRL utils has done is it goes out and inquires, hey, what port on the VIRL server is the console for this device currently connected to, and just let me connect to it through telnet that's out there. And so it makes it really easy to kind of connect out to these devices that are there. And again, I'm at the console port that's here. When I first started the telnet application in Linux and Mac, the way that you get out of telnet to go through is this control bracket, or this control bracket key. And so we print this out so that we know how to get out of the console port, because I don't know about you, David, but have you ever gotten yourself stuck into a device in a mode and not know how to get out before?
Oh yeah, definitely.
So just the control key and then the square bracket, and again, that's the keystroke in the telnet application on my Mac, and then I can just quit. And so I've now disconnected from that device. Do VIRL nodes again. There's still the hello hasn't finished showing they're reachable, but I bet they are. I can probably just do VIRL SSH into iOS v-1. And so this will SSH me directly to. And in this case, these 172 addresses are set up to be kind of routable into the sandbox. And so now you can see it's prompting me for the password. This particular banner image kind of is wrapping a little weird, but all right. So now I've SSH'd into this device. There it goes. And show line. And so now we can see I'm connected again at a VTY line, in this case, as it goes through. And so now I don't have to necessarily know the IP addresses, the ports that these devices are connected to. I didn't have to be in VM Maestro, and I don't even have to be in the web interface, but I can fully interact with any of these devices that are out there. And I could configure these if I wanted to use CLI, config T. Again, I'm SSH to the device, but I didn't have to think about or remember all of the things, like what IP address was automatically assigned to this device. VIRL nodes will tell me what IP address was there, but I can just simply do VIRL SSH to whichever one of these node names I'm after. If the device didn't support SSH, Telnet would work as well, so VIRL Telnet into iOS v-2 will let me Telnet into those devices. And Cisco, type the username wrong, but the default credentials in VIRL are Cisco. And so now I'm on iOS 2, and just to kind of, as we've been doing again, now I'm again on a VTY line, so I'm connected directly into it. I can exit out of there. So this gives me, again, now we've spun up a simulation that's there. Now when I did that remember I started this all off with VIRL search. And I have these lists. So the question might be like, where are these coming from, Hank? Like these magic little topology files. So let's go find them and just show. And so,
yeah, and Hank, another question, because I must have missed it, is how does it know which VIRL server to connect to? Did I miss a step?
I haven't mentioned it yet. Well, let me finish this and then we'll circle back to that.
Yeah, no worries.
As well. So up on GitHub, so github.com/VIRL files is a GitHub organization that we set up specifically for hosting sample VIRL topologies. And so when I ran VIRL search, what VIRL Utils is doing is just looking at this GitHub repo and saying, oh, there's these ones have been created. When I keep saying we, a lot of the development on this was done by one of my fellow Cisco engineers, Kevin Corbin. He's a super great network engineer programmability guy. And so he's done 90% of the development here. I contributed a little bit occasionally, several ideas. But that's the we that's in this. You can see there's a group of folks that have contributed back to here. But we're also always looking for common VIRL files to host for folks. And so if David, if you or if anybody else that's watching the video has created a VIRL topology file that that's interesting that you think would be valuable for folks, we can post them here in this GitHub repo, and then they show up whenever anybody does a VIRL search. This just live goes out and looks. And then when I VIRL upped, remember the command I ran was VIRL up, and then I just gave it the name of the one that I wanted. In this case, it's again the 5-router mesh. And so if I go look at 5-router mesh, we can see, excuse me, we can see there's this topology.virl file. This is the file that drives that. And so if I look at it, we can see it's an XML file. That's just, this is what, when you create a simulation inside of VIRL, when you drag it in that topology, under the hood, it's creating this file. And so this one was probably originally created in a console like that, exported, and then put here. But when I VIRL upped, what it actually did is it downloaded that topology file. And so if I look, I now have topology.virl file here. It pulled it down from GitHub for me. So I have my own version of that file that's in there, and that's what drove the simulation. And so if I were to VIRL down, it would shut it down, but that file would still be there. So I could immediately just VIRL up to turn it back on. And so again, if you're working off of our shared sandbox, you VIRL up, you work on it a bit, you VIRL down, or your sandbox reservation expires, you reserve another one, you VIRL up again, you get the same topology back. Because again, we're storing our topology, our simulation information, along with some code. And we can see here in a second, we're going to talk about some Ansible stuff that goes through on that side. So the next question I'm going to answer is, how does VIRL Utils know to talk to the VIRL server? But before I answer that one, any question on kind of how we're getting the topology and some of those other pieces?
Yeah, I mean, Hank, another question that you can answer later is, does the VIRL topology file contain the configurations and the topology? So like in GNS3, you have a topology file, but you also have configuration files. Does that file contain everything?
Yeah, so it can contain the configurations. And so remember how when we were in the simulation, we did the auto netkit and then we looked at the configuration that was created?
Yeah.
what goes in the topology file is that config. So here, if I look, this is the topology file, and we can see here is the entry key is config, and then baked in here is a configuration. And so if you wanted to include some baseline configuration for the device, you could include it here. And again, it's a text file. You could come in and tweak any of this and save it and use it. Now, once you've brought a simulation up and you've started it, if you connect in and you manipulate the configuration, so you change the OSPF config, you configure EIGRP, turn on MPLS, whatever it is, any of those configuration changes you make after you've started the topology exist on the topology in the device. They don't automatically get written back into the topology file. VIRL has a feature where you can go through and you can say, I've made a bunch of configuration changes to this topology. Please, like, what do they call it? I think it's export or pull out the config from the current running config and update the topology file. And so now you would save those, but that's an extra step. And again, I actually like that. I want to be able to have a baseline config, maybe make some changes, and then it's up to me whether I want to update my default starting configuration point or not. Does that make sense?
Yeah, I mean, that's great. From a labbing point of view, a lot of guys like to have an initial lab and then like a set of tasks and then the final config so that they can verify things. So that's great from like my point of view. I could create lab guides and labs for others to use where there's an initial config, which is this base one, and then a bunch of tasks and then a final config.
Mm-hmm. Absolutely, absolutely. Okay, so let's answer the question. Is where's the magic? How does VIRL know what to talk to? There are a couple of ways that VIRL running on your local machine, in my case, my Mac, know how to talk to or know what VIRL server I want to talk to. The first one is it will ask you. If you haven't used some other method, when you go to run a command like VIRL ls, if you haven't done a step that I'm going to show you in just a second, and so it doesn't know which one to go through, it would just ask you, hey, what VIRL server do you want to talk to? What username, what password? And that's okay. But what I usually tell people is if you are using, if you've got a common VIRL server you always go through, VIRL utils is set up to look for a particular file called VIRL RC. And we're gonna, I'll show you mine and then we'll look at the docs. And so in the local folder that's there, let me actually, I'm gonna copy it over because there's a couple of ways this goes and I don't want to confuse people. I'll just turn VIRL RC2, all right. So the first place that VIRL is going to look for is in the local folder. So I'm going to do an ls-la. It's going to look for this file called .virlrc. And so an RC file, we kind of modeled this after something out of kind of the cloud in the OpenStack world. And it's an environment file. And so if I look at this type of a file, if we just take a look at the contents of that file, virlrc, we can see that it is simply set up with some just variable kind of placements. And so these first three, I've got a couple of different VIRL servers I sometimes use. This is one of them, but the hash symbol, the number symbol at this part, says those are commented out. And so the ones that are currently active are these at the bottom. So VIRL host equals 10.10.21.60. Again, that's the IP address for the VIRL server in DevNet. The username and password are guest and guest. And so the simplest way, and the way I tell most folks, is just include this .virlrc file along with your code in the directory you're at, and then VIRL will look for those. Now, if you have lots of projects that are running off of a VIRL server, you can also put the .virlrc folder file in what's called your home directory. And so on a Mac, that is, or on a Linux or a Mac machine, that's often represented by the tilde. And so if I do dash tilde dash, the tilde key, and then I can look, I've got a VIRL dash tilde grep for VIRL. And grep for, oh, it's a hidden file. That's what the dot means. So we can see here, we've got this .virlrc file that's in my home directory. That tilde slash is your home directory. And so if you put the file in your home directory, then no matter where you are, any project will always be able to find the VIRL server. So to reiterate, the way that VIRL utils knows what VIRL server to talk to is if it can't figure it out based on one of these files, it will ask you. Or it will look first in your local directory to see, do you have a .virlrc file, whatever directory you're currently sitting in. And then if it can't find one there, it finally goes and looks in your home folder, which again on Windows or a Mac or a Linux machine is represented by a tilde. I think it's like %home % on a Windows machine. And that would be on a Windows machine like C users / whatever your username is. That's your home folder on a Windows machine. Is it goes and looks for this .virlrc file that goes through. And all that's in there is just some variables. What's the host, username, and password for your VIRL server? Does that make sense?
Yeah, that's great. I think the important thing is when you run it for the first time, it's going to prompt you if it doesn't know what to do. So
yep.
When it prompts you, does it save that, or do you just have to create this file?
No, I think the way that it's built right now is that it would just prompt you each time. And if you get tired of typing it each time, it's just create this .virlrc file. The docs that we were looking at before up on, do I still have it open here? Yeah. Over here is inside of the configuration. So right in GitHub on the documentation, it says there isn't much to configure, how to set up your VIRL credentials, VIRLrc in the working directory. So again, whatever folder you're currently in, or you can set them as environment variables as well, or you can put it in your home directory. So again, it's just the details are here in the docs. And we'll make sure we've got a link for this information in the show notes as well.
That's great.
Mm-hmm. So that's how it connects in on that. All right, so as we are coming to the end of this, there's one last thing that I'm hoping that we can kind of get through. And so as I mentioned, when I'm working with VIRL today, it's often not because I need a network simulation. It's because I'm trying to work with some tool. Maybe it's Python scripting, maybe it's a config tool like Ansible, or one of Cisco's tools like PyATS or NSO. And so starting a simulation is just kind of the first piece of what I'm after. We then want to use this for whatever tool or whatever other piece we're after on that as well. And so there's a command called VIRL generate that's built in. And we can see this will actually generate inventory files for some common NetDevOps tools. And so Ansible, NSO, or PyATS. And so I can come in here. And so again, we've got a running simulation going. It's got 5 different devices that are in here. And I can say VIRL generate Ansible. This will generate an Ansible inventory file. And if folks that are watching aren't familiar with Ansible, Ansible is it's a configuration tool originally for servers, but can be used for networking. It's written in Python, and it's a way to kind of manage configurations across your a network that's there. And it's becoming quite common for folks in the network automation space. And so what you need to use Ansible is an inventory file, kind of a list of what devices do you want to manage that are there. And so oftentimes that's the first step when working with Ansible is to create an inventory file. Now, when you're working with a simulation tool like VIRL or any of them, that inventory file will sometimes change because you don't know how many devices are there, you don't know what management addresses they have, other types of pieces that are in there. And so to make the process simpler, we built into the VIRL utils this generate capability that will automatically do some of that heavy lifting based on the current running simulation that's there. And so we can see here, it gave me some information. It said placing iOS v1 and 2 into this group headquarters, 3, 4 go into this data center, and then 5 went into this group called branch. And so it created a new file for me called defaultinventory.yaml, which is my Ansible inventory file. So let's go look at that file real quick just so you can see what's in there. And so I just switched over here to Atom, which is a code editor. Make this a bit bigger. And so this bit at the top is some information that's helpful for folks that might be using this. And so the way VIRL utils works is it creates an inventory file and it gives you the option as the topology creator. So whoever created the topology file that drove your VIRL simulation is you can add some references in there. So down here in this little block, we can see that there's this entry key Ansible group. And so inside of an Ansible inventory file, oftentimes you'll group your devices into different types that are there. And so you can include that in your VIRL topology file, and so we can automatically create that appropriately. And so in this topology file, there was a group for headquarters, data center, and then branch, and the devices were kind of parsed away. And so the VIRL generate Ansible created this portion of the file, the part that's all active. And so we can see it's the all group has a child called headquarters. The headquarters group has 2 hosts, one of iOS v1, one of iOS v2, then the group of data center, and then there's some hosts there. And then these Ansible host variables, console server, and ports were all pulled dynamically through the APIs from VIRL to populate this. And so I didn't have to manually go say, well, what IP addresses were assigned to these devices? What ports are currently active to connect to these devices? It all gets written automatically for me. And so I've now generated my inventory file. And then inside of my folder here, along with my topology file, I've got this example1.yaml, which is just a really simple Ansible playbook. And so I can go ahead and immediately Ansible playbook, and then we'll just say example1.yaml, and this will run. And so the idea here is you can include, when you're writing some sample scripts or automation, you include your topology file for whatever you're testing against, you include your scripts, and then you let VIRL automatically create the inventory file, because that's the dynamic piece. That's the piece that's going to change for every user that's out there. But under the hood, everybody's still using the same code, using the same pieces. And we can see this is processing. And this playbook simply just goes and gathers some details about the switches, and we'll print them out as it goes in. So while this is finishing up, any questions, any clarification on that bit that was there, David?
Yeah, one thing I forgot to ask you, Hank, is when you use the VIRL up application, we didn't look at the topology through the GUI, but I'm assuming the topology is there and I could look at the topology through the GUI, yeah?
Yeah, fantastic. Great question. Yes. All we're doing is we're manipulating it. So here, I'm again, this is the same exact web page we were at before. We can see that VIRL demo simulation default. So it created this random name for it. And if I click on it in here, this will open up that simulation.
Yeah, so I mean, you're just manipulating VIRL through an API for those people who aren't used to this. So
correct.
You're basically coding it remotely using an API rather than a GUI, but the results are the same.
Exactly, yep. So here we're looking at the simulation. If I hit the live visualization, this will load up and it'll build out. We can see there's the 5 router mesh that was created. It's the exact same simulation that was there. The value of doing it through the API and the tooling is speed and repeatability. If I'm just creating a simulation once, it's going to be super easy. I'm only going to do it once. It's fine. But if I'm going to use the same simulation, or if I've got an entire team that's going to use the same simulation, it doesn't make any sense for all of us to have to point and click 100 times. And so we just include that with the code, and then that VIRL up capability just manages it under the hood. But I can still, nothing prevents me from, once it's up, going in here and using those tools. Remember, I could go through and say, go collect the information that's out there. It's still the same VIRL system. It's just a different way to manage it on that side. And so by now,
So here's another question for you. If I, let's say, as a trainer or instructor, created 50 topologies that I wanted to share with people.
Yep.
Would you recommend that I share that to your sort of shared portal? And then guys can just use VIRL up to download that and then create the topologies. Is that the simplest way to do it?
So that would be a fantastic way, and we would love to host those for you, David. If you set them up, we can set you up. We can and get them posted, and then people could go through. When they did VIRL search, they would show up here in this list, and it could say David Bombel _ CCNA Lab 1 after VIRL files. Or if you didn't want to do that, and again, we're more than happy to do it. I'd love to have them in there. You could put them in your own repo, and then when I did this, I just did VIRL up, and then I grabbed the short version of this. Let me grab it. I just did that. Under the hood, it's assuming we mean GitHub and all this other stuff. If you posted it in your own, you could go, and if someone had a private GitHub, you could do github.com/davidb/ccna1. I mean, you could put a full path in. It's defaulting to ours. And if you create them, we'd love to put them in there. I'd love to fill. Our goal is always to fill this up and have lots of really good starting topology files that anybody can start with for different projects.
Yeah, so that's a good one, Hank. If people want to submit topologies to you, because you could get hundreds of these. Yep. What's the best way to do that? Is it to send you an email, or how do they submit their topologies? Yeah,
so we've been working through it. So normally when you work with in GitHub, we always tell people, hey, fork and do a pull requests. That's a great way to contribute to an existing topology. So if someone sees an issue or wants to change one of these, that's a great way. New topologies are a bit tougher, and we're working on a good way. I would say for now, if someone has a topology, have them send me either an email or reach out on Twitter while we work on a much more efficient mechanism to get them kind of added and hosted in there, which is probably going to turn into some sort of a form for where someone can go and post, and then it would go in so we can look at it and automatically do it. We got to build some automation to build the onboarding of new topologies to make it easier. It's still fairly new, so we're a bit old school in the communication mechanisms right now.
Yeah, so I think let's suggest that if people want to submit topologies, they send you a message on Twitter, and then you can take it from there. Because like in GNS3, they have a way where you can submit topologies. So, I mean, for guys who prefer using VIRL, this is a great way to do it.
Yeah, we'll get all those pieces in. And like I said, we're working on better ways for submission, but for now, reaching out on Twitter would be great. So as we finish up, just to kind of hone down again, we ran that Ansible playbook. The inventory file was automatically generated for me, and it printed out. And in this case, the playbook didn't do anything other than just gather details about the devices, but again, it could go configure different pieces in all the areas that are there. And so, as in summary, my goals for today were to show, okay, VIRL is probably come a long way if someone hasn't looked at it in a couple of years. Make sure you take a look at that web interface so that you get comfortable. You don't need the thick client. And particularly around the automation areas and working it into your workflows is take advantage of VIRL utils to start driving and including kind of in your workflow with your Python scripts or playbooks and other things that you're working on. That's what I wanted to hit today, David.
Yeah, that's great, Hank. I really want to, as always, thank you for your time. Thanks for sharing, your knowledge. So just so that everyone's aware, this is the last call Hank and I are going to have this year in 2018. But I think, Hank, we should have more calls on VIRL because it feels like we're still just scratching the surface of, should I say, of what you can do with VIRL. So if you're up to it, perhaps next year we can do some more videos.
We'll definitely be back next year with lots of different videos, and I'm sure that we can deep dive into VIRL and all sorts of other stuff that I'm looking forward to talking about. But yes, we will be back in 2019.
So Hank, with that, I want to send you, my thanks from the other side of the world. Thanks for, spending so much time with me this year and sharing so much information. Hope you enjoy Ireland, and we'll probably chat next year.
Sounds good, David. Enjoy the rest of your vacation. Talk soon.